All right, so I want you to imagine something for a second. Picture yourself standing in the middle of a casino. The lights are flashing, the noise is just overwhelming.
Okay.
And you're at the high stakes roulette table. But the chips in your hand, they aren't for money. They represent your entire
The
existence.
ultimate wager.
Exactly. And the standard bet, the one almost everyone makes, is on black. That's your traditional burial, your cremation. You know the outcome. It's final. The house takes your chips. Game over.
Right.
But then someone taps you on the shoulder and they whisper about the secret side bet. The buy-in is like the price of a Ferrari. The odds are historically awful, but the payout?
What's the payout?
The payout is pressing pause on death itself and waking up in the future.
It sounds like pure sci-fi, but for a really small, very dedicated group of people, that side bet is a reality. It's cryopreservation.
Yeah.
It's this gamble that if we can cool the human body down fast enough and deep enough, we can stop biological time.
And just wait. Wait for a future that can fix whatever killed you. And that is exactly what we are unpacking today. And I want to be clear right up front. We aren't just riffing on Futurama here. We've gone through a stack of medical journals, court transcripts, even some surprisingly deep Reddit threads to figure out what is actually possible.
And we're not just talking biology. We're also talking about the law.
Oh, yeah. We're going to get into the hard chemistry of why you can't just, hop in a freezer, the weird history with microwaved hamsters,
Yeah.
and the actual trauma trials happening in ERs right now. But you're right, the legal side, it's a minefield. When you try to define death as a pause instead of an end, you run into some massive conflicts.
Huge conflicts with family, with inheritance,
Yeah.
with the definition of what it even means to be human.
But before all those nightmares, we have to start with patient zero, the first guy, James Bedford.
Yes.
I was looking at his file, and it's just kind of wild to think he's been on ice since 1967.
That's right. January 12th, 1967. He was a psychology professor, died of kidney cancer, and within just a few hours, he became the first person to be legally cryopreserved.
Legally. That's a key word there.
Oh, absolutely.
Yeah.
He's basically the longest-running experiment in the whole field.
Yeah.
He is still preserved today, right now, in a tank at the Alcor Life Extension Foundation in Arizona.
More than 50 years suspended in liquid nitrogen. And this brings me to the first big hurdle, the thing that I think trips most people up. If I take a steak out of my freezer, okay, it might have some freezer burn. But when I thaw it, it's still a steak. The structure is there. Why is the leap from frozen steak to frozen purser so impossible right now?
It all comes down to structural integrity, but at the cellular level. And the steak analogy is okay, but the one I prefer, and it came up in the research, is the onion ring. Or, even better, a fresh strawberry.
The mush factor?
Exactly, the mush factor. If you take a fresh, plump strawberry, you put it in the freezer, and then you thaw it out, what happens?
It just collapses. It's a wet, soggy blob.
Right, all that crispness is gone. And the reason for that is water. Humans are, 60% water?
Something like that, yeah.
And when water freezes, it does two things. It expands and it crystallizes. And this is the key takeaway for the chemistry part of this. Ice crystals are not smooth. On a microscopic level, they are jagged, they're sharp, they're basically tiny knives.
So if you just lower the temperature, those crystals form inside your cells and puncture the cell membranes from the inside out.
That's it. You're shredding your own cellular machinery with millions of tiny ice daggers.
You're turning a complex biological machine into, cellular soup.
Precisely. And once those membranes are shredded, there is no putting Humpty Dumpty back together again. That is why freezing is actually the enemy of cryonics. You don't want to freeze the patient. You want to vitrify them.
Vitrification, I saw that term everywhere. It comes from the Latin for glass, right?
That's the root. The goal is to get to a state they call an amorphous solid. You want to cool the body down to, say, below minus 120 Celsius, but you have to stop those water molecules from clicking into a crystal lattice.
You want them to just stop moving, like a snapshot in time.
Exactly where they are. And to do that, you have to get the water out. The process involves draining the blood and replacing it with cryoprotectants.
Which is really just a fancy clinical term for
Medical-grade antifreeze.
So in a perfect vitrification, you pump the body full of this stuff, cool it down, and you basically become a glass statue. Your cells are intact, everything's locked in place, no ice crystals. So on paper, it sounds like problem solved. But there's a huge catch, isn't there?
There is always a catch. The catch come to here is that the cryoprotectants themselves, they're toxic.
Toxic like make you feel sick, or toxic like kill the cells.
Toxic, like they denature proteins and effectively poison the tissue. To prevent freezing in something as big as a human body, you need really high concentrations of these chemicals. And at those concentrations, they're lethal to the cells.
So you're stuck. You can either be shredded by ice or you can be perfectly preserved by poison.
That is the current state of the art. That is the paradox. The gamble that James Bedford took and that people are taking today is that future technology will solve this.
They're betting on nanotech, right?
They're betting that in, say, 50 or 100 years, we'll have advanced nanotechnology that can go in, scrub the antifreeze out, repair all that toxicity damage molecule by molecule, and then restart the system.
So you're paying for a ticket to the future, but you're just building the departure terminal and hoping someone invents the arrival terminal before you land.
That is a perfect analogy. And for a lot of skeptics, that's where the conversation ends. It just sounds like pure fantasy. But, and this is where it gets really interesting, nature has already figured this out.
The frogs. I honestly love this part. I was reading about Rana sylvatica, the wood frog, and it feels like something out of a comic book.
It is the absolute poster child for natural cryopreservation. This little frog lives way up in North America. In the winter, it doesn't just hibernate, it freezes solid.
Like rock hard.
Right.
No heartbeat, no breathing.
No brain activity. You could literally drop it on a table and it would make a clunk sound. About 65% of the water in its body turns to ice. By every medical standard we apply to humans, that frog is dead. But when spring comes, it thaws out. The heart kickstarts, the brain comes back online, and it just hops away.
Okay, so how does it beat the onion ring problem? Why don't the ice crystals shred its cells?
It has a built-in pharmacy. The moment it feels ice on its skin, its liver goes into overdrive. It floods its bloodstream with massive amounts of glucose, urea. It basically turns its blood into a thick syrup.
So it makes its own antifreeze.
Essentially, yes. This high sugar concentration packs the cells, and it prevents the water inside the cell from freezing, even while ice is forming in the spaces between the cells. It keeps them from dehydrating and collapsing.
So it manages the ice instead of trying to stop it completely. That is incredible. And it's not just frogs, right? I saw a note about nematodes.
Yes, those tiny roundworms. There was a study, I think in 2018, where researchers found nematodes in the Siberian permafrost. These things had been frozen for something like 40,000 years.
40,000. That's the Pleistocene. We were sharing the planet with Neanderthals when those worms froze.
Correct. And when they warmed them up, they just started moving and eating again. It proves that biological information can be preserved, basically indefinitely if the conditions are right.
But frogs and worms are one thing. A human is a whole other level of complexity. There is, though, one experiment that really bridges that gap to mammals. And this was the part that just blew me away. The connection between all of this and the microwave oven.
The hamster experiments. This is a great piece of forgotten science history.
Yeah.
Back in the 1950s, a scientist named James Lovelock,
The Gaia hypothesis guy.
the very same one, he was working on freezing and reanimating small mammals, hamsters. And they figured out how to freeze them without killing them, but the problem was warming them back up.
Right. If you put a frozen hamster in hot water, the skin warms up, but the heart is still an ice cube.
Exactly. You get thermal shock.
Yeah.
The warm tissue demands blood and oxygen that the frozen heart can't supply. It causes massive damage.
So they needed a way to heat the hamster from the inside out, evenly.
Which didn't exist. So Lovelock and his team looked at surplus World War II radar equipment. They took a magnetron, the thing that generates radio waves, and built a metal box around it.
They minted a microwave oven to reanimate frozen hamsters.
They did. It was the direct technological precursor to the one in your kitchen. And the crazy thing is, it worked. They successfully revived a significant number of these hamsters. It proved that mammalian tissue can survive this if the heating is uniform and rapid enough.
Okay, so we have syrup-filled frogs, ancient worms, and microwaved hamsters. But that's all animal data. The most shocking thing I found is that we are actually doing a version of this on humans right now.
This is where we pivot from science fiction to medical reality. It's a procedure called emergency preservation and resuscitation, EPR.
And it's important to stress this isn't for people who are already dead. This is for trauma patients.
Correct. This is a clinical trial, mostly at the University of Maryland.
Yeah.
It's for very specific cases, usually a gunshot wound, a stabbing, where the patient has lost a catastrophic amount of blood and goes into cardiac arrest.
So your heart stops from blood loss, and surgeons have maybe 5 minutes to fix the hole before your brain dies from lack of oxygen, which is just not enough time.
Never enough time. So EPR buys them time. The surgeons literally replace the patient's remaining blood with ice-cold saline solution. They rapidly cool the body down to about 10 degrees Celsius, that's 50 Fahrenheit.
Which is profoundly cold for a human being.
It induces a state of, well, they call it suspended animation. At that temperature, metabolic activity drops to almost zero. The cells don't need oxygen. And this buys the surgeons not 5 minutes, but 60 to 120 minutes.
Wait, so you can have a human with no heartbeat, no blood flow, flatline brain activity for 2 hours. They fix the wound, warm them up, and they come back.
That is the goal. And the early data suggests it is possible. It is proof of concept that we can press pause on a human life, fix a fatal error, and then press play.
That feels like a massive bridge. I mean, if we can do it for 2 hours, why not 24? Why not a week?
That's the slippery slope. But EPR uses mild cooling, 10 degrees Celsius. Cryonics is minus 196 degrees. The difference in potential damage is exponential. But what EPR does is validate that core idea. Cooling preserves the brain and halts the dying process.
So biologically, we're on the edge of maybe. But as we dug in, it became so clear that the biology might actually be the easier problem to solve. The legal and ethical side is a nightmare.
It is a total mess because the law is binary. You are either alive or you are dead. There is no legal category for currently paused.
And this creates real painful conflict. The case that really stuck with me was JS from the UK. I think it was 2016.
That was a heartbreaking case. JS was a 14-year-old girl with a rare terminal cancer. And she was incredibly articulate. She decided she wanted to be cryopreserved.
She wrote a letter to the court.
Yeah.
Right.
A gut-wrenching letter. She wrote, "I'm only 14. I don't want to die, but I know I am going to. I think being cryopreserved gives me a chance to be cured and woken up, even in hundreds of years' time."
But because she was a minor, she couldn't make that call herself. Her parents were divorced and they completely disagreed.
The mother was supportive. The father was not. And his objections were, well, they were practical. He asked the court, even if she comes back in 200 years, she may not find any relatives. She might not remember who she is. She'll be a 14-year-old girl alone in a strange country.
It's the Rip Van Winkle problem, but so much worse.
And the court had to step in. The judge eventually ruled in the mother's favor so the girl's wish could be carried out. But the judge also noted the complete chaos that happened at the hospital.
The part about the volunteers.
Yes, hospitals are sterile, highly regulated. When JS died, this team of cryonics enthusiasts, not medical staff, had to come in with their own equipment to start the process. The judge said it caused real concern for the hospital staff. It just showed how unprepared our systems are for this.
It's a collision of two worlds. And it's not just hospitals, it happens in families. We saw the term hostile spouse pop up a lot.
It's a huge issue. I mean, cryopreservation is expensive. You're looking at around $200,000 for a full body, maybe $80,000 for just the head, what they call neuropreservation.
We should definitely get to that. But that's $200,000 that comes directly out of the estate, out of the inheritance.
Right. And if you're a spouse or a child, and your father decides to spend a huge chunk of your inheritance to freeze himself, that can create a lot of resentment. There are actual legal battles where families try to invalidate the contract after death just to get the money back.
The most famous example has to be Ted Williams.
The baseball legend. That was a spectacle. His will clearly stated he wanted to be cremated. But after he died, 2 of his kids produced a family pact written on a grease-stained napkin.
A napkin. Seriously.
A literal napkin. It said they all agreed to be frozen. His oldest daughter fought it, arguing, a napkin shouldn't supersede a formal will. It became this bitter public fight.
And the napkin won.
The napkin won, mostly because the daughter ran out of money to keep fighting. Ted Williams is currently frozen at Alcor. But it just proves that even in death, you aren't safe from all this earthly drama.
Which brings us to the probability of it all. Skeptics look at the drama, the toxic chemicals, the lack of a revival method, the cost, and they say, this is a scam. You are selling false hope.
And taking a lot of their money for it.
But the counter-argument, the one from the cryonicists, is basically Pascal's wager, isn't it?
It is. If you're buried or cremated, what are your odds of waking up in the future?
0.
Absolute 0. But if you are vitrified, even if the tech is crude, even if the company is shaky, the chance is non-zero. It might be tiny, 0.1%, but it's the only option on the table that offers any chance at all.
But that non-zero chance relies on so many things going right. We're talking about 100 years, maybe more. What company even lasts that long?
That's the company longevity risk. These places are usually set up as nonprofits or trusts to try and ensure stability. But if they go bankrupt in 2060, the power gets cut, the liquid nitrogen stops flowing.
And the bodies thaw.
And it's all over. You're betting on their asset management as much as you're betting on future science.
And okay, let's say you win the bet. The company survives, the nanobots work. You wake up in 2126. We touched on this with the JS case, the lonely future.
There was a really poignant thread about this in our sources. One person described the fear of becoming a zombie employee.
A zombie employee.
Imagine waking up. You have no money, your skills are obsolete, you were a coder, but now computers don't use code. You were a truck driver, but everything is automated.
You'd be a biological relic.
Exactly. You might be an indentured servant, revived, just to work off the debt of your own resurrection in a world you don't understand, surrounded by people who see you as a museum piece.
That is a terrifying thought. You cheated death, but you didn't necessarily save your life.
And yet, for the people who sign up, that curiosity outweighs the fear. They want to see what happens next.
Okay, there's one final, really existential wrinkle here. You mentioned neuropreservation, saving just the head.
Right. The logic is that you is your brain, your consciousness, your memories. The body is just a meat suit that can be replaced.
So the idea is that in the future, they can either grow you a new body or just upload your brain to a computer. But this leads to what some people call the teleporter paradox. If I scan every neuron in your brain and upload that data into a supercomputer or a new clone, is that actually you?
That's the ultimate question. Is consciousness continuity, or is it just a copy? If I burn a book and then reprint it perfectly, the story is the same, but it's a different physical object.
So if they rebuild you in 2126 from the map in your frozen brain, does your actual stream of consciousness transfer over? Or did you die back in 2026, and this is just a really, really convincing digital twin?
And that is a question that biology can't answer. That's pure philosophy.
It is, and that's why this whole thing sits on this razor's edge. It's part medicine, part estate law, and part faith. You're trusting a future priesthood of scientists to resurrect you.
That's a good way to put it.
So, to bring this all together, we've come a long way since the 60s. We have vitrification to stop the ice. We have EPR proving we can cool people down to buy them time. We have nature showing us it's possible. But we are still standing at the edge of a very long, very dark bridge.
And we haven't built the other side yet. But for the people in those tanks, standing on the bridge is better than falling into the abyss.
A non-zero chance.
A non-zero chance.
I think that's the perfect place to leave it. It's a heavy topic, but it really forces you to think about what it means to be alive. Thanks for taking this dive with us.
Always a pleasure.
And to our listener, if you had the $200,000 and the choice was final, would you take the bet? Something to think about. We'll catch you on the next deep dive.